So can you hear me now? You can hear me now, and let's continue with ggplot today. And last time I let you to do one home exercise, and I'm going to continue right now. I'm going to do it myself. But first of all, I'm going to create a new file, new file. Oh dear. R script. And I'm going to save it as session. It's already session 5 with us. So we have today we will be after this day's lecture ends, we have been studying our 10 hours already, but you are already getting ready. Believe me, I have some more hours of art to give you, but you are already getting ready to be sent outside and do your stuff in R. Now, I'm going to load in library tidyverse, Control Enter, library tidyverse, Control Enter. This loads in the libraries that we are going to need today. One of the important library we are using is ggplot2. So this library tidyverse and Control Enter. And I'm going to read in the PIAC dataset again. You should have it already. If not, then please read it in. No, not PIAC dataset. PIAC dataset we are going to use as well, of course. Yes, okay. PIAC is read.csv, http www.utee-esep.piac eng.csv. Going to copy it to the chat as well. And then what was the second question about this last time, which we left unsolved, is first I'm going to load in library. What library do I need now? Let me quickly look at, yeah, the last time. Gapminder, library Gapminder. Gapminder, and I made a big mistake last time. I said you to that you should take the filter out the 2017, actually 2007. So Gapminder 2007 is filter Gapminder year is equal to 2007. 2 equal signs, not 1 equal sign, not 3 equal signs, 2 equal signs. And also Gapminder to 1964, was it? 1962, 2007. 1962, 2007 is filter Gapminder year percent in percent and vector of values where it can be 1962 and 2007. So I created these 2 data sets, and if you look at these data sets now, for example, Gapminder, Charlie, it's interesting that you have this now, this error, because yesterday it worked, but you need to install package stringy then. So install packages stringy, and then it probably shows you some other packages that are missing, and then just continue installing them until you will get it. But you have a new computer or something, new installation, because it should have showed it yesterday already. So I took these 2 subsets of this data set. One has only year 2007 in it, and one has 2 years in it. Now, if we are going to visualize this now, then you first start with ggplot. What data set are we visualizing? Data is Gapminder 2007. What is connected to x-axis? AES. always inside aesthetics AES. When you are connecting something, X is connected to, what is X connected to? Let me take a quick look. GDP per capita, GDP per cap. X is connected to GDP per cap. Y is connected to life expectancy. Plus, no, not plus yet. One. I'm missing one parenthesis. Plus Geom point. Let's see what happens. Well, this is what happens. We have these countries. Every point is a country, and you see that that it's kind of not like it looks at the graph at all. What we need to do now, we need to let me start building up the graph. So first, the point size has to be connected to the variable population. So AES, as well as I am connecting this size to something inside the data set. Then it's inside AES. Size is pop. Connecting size to population. And now we have bigger balls and smaller balls there. So now let's connect the size to population, and color is connected to continent. And now we have some colored balls there. Now let's make x-axis to be logarithmic axis. So plus scale x log 10, and x-axis is logarithmic axis, and it starts to look like the graph that is on the graph that we want to. What else do I need to do?
Scale size area.
Scale size area. Okay, yes, exactly. This is something that I want you to know. And this is, while most of the, even ggplot creates these graphs, and the standard default values are usually, the defaults usually make sense. Then there is one thing that does not make sense very well. So right now, the size is connected to population. And really, the bigger the ball, the bigger the population. But what you want to do, you always, when you connect size to some variable, you always want to add scale size area. And why is this? Now you see that the balls actually, they change their size. Now the area of the ball is connected linearly to the size, to the population variable. Otherwise, a bigger one would be bigger, smaller one will be smaller, but the area is not connected to that. The area is not, you know, when one thing is 2 times bigger than other, then the area of the ball should be 2 times bigger than the other. This is how humans, you know, how what we can logically see or consume this data, that now we see that really there are 2 big countries here perceiving each other. Now there are 2 big countries here, India and China, and the size of these balls is actually it's you know, 1 billion compared to other countries. What I also want to do, because these balls are overlapping, then what I want to do is I want to make alpha is 0.5, for example, and then this you can see through. Some of the balls are on top of each other. You can see through it. The scale size area, it provides you, for example, there is one parameter that you can put inside here. It's max size. Let's set it to be, for example, 12. And you see now the balls are even bigger. So if you want big balls, this is how to do big balls in R. Yeah. And let's add some plus key minimal, and we have a nice looking graph. You see that this population, this legend here, it looks funny. It's 2.3, it's 2.3 to the power of 8 and so on. To 10 of to 2.3 times 10 to the power of 8. So if you want to change this, then you should add plus scale. I already have the scale size area here. If I want to change this, then I can, for example, say that comma breaks is, and I'm going to show actually this to you later in the later time, but breaks is, for example, 1 million is a 6, 10, 100 million. Oh dear, 100, 1, 2, 3, 4, 5, 6, and 1 billion. 1,000, 1, 2, 3, 4, 5, 6, whatever I did now. Now it shows 1, 2, 3, 4, 5, 6, 7, 8, 9. How many zeros are in billion? Well, let's assume it's this comma and not breaks, but now I'm adding one more parameter. I'm adding parameter labels is also a vector, let's say million, 100 million, millions, and billion. So now it shows me 1 million, 100 million, and 1 billion. In this legend. In this legend. Now, if you want to create this graph to show both years, then what I would do, I would copy and paste this graph what I did for 1 year. But now I'm going to change the data set to not 2007 but 1962 2007. And now it shows you all the countries 2 times. If I want to show it on next to each other, the faceted graph, then I would add plus facet wrap, by which variable are we faceting year, and we have this faceted graph. So it shows you how much has world changed during this time. You see these big balls, China, India, they have made quite growth, but also every other country has made quite a growth during this time. It's actually been amazing. So I am 44 years old now, right now. And I started to study economics when I was 18. And just to watch the world grow during this time, since I was 18 or during these 26 years, it has been amazing. Many people I know today you are watching from countries with quick development and high developing countries, and it's you are doing great, people, and also Estonia is doing great. Estonia, when I was young, Estonia was quite a poor country. We got out of Soviet Union in 1991. And we were quite a poor country. The average wage was something like 50 euros per month or something like this. Right now, the average wage is 1,800 euros per month, and it's growing quickly still.
I have a question. Can
Yes.
you please explain again that here in Geom Point, we already we gave that the size of the bubbles should be equal to the population. So then what is the difference between giving scale, size, area? Here also the size is corresponding to the population only.
So
then what is the difference between these two commands?
So scale size area says that the size should be that the area of the ball should be connected to the size, not just that bigger balls are bigger numbers, but that it connects specifically area.
Area of the country?
Not area of the country, but area of the ball.
So like the area of the ball will correspond to the area of the country, or it will correspond to the population?
To the population of the country.
So like my question is like how to decide like if we just want to go with the size is equals to population, or we should give the command scale size area?
Always give the scale size area. Always. There is, well, the point is that if you, let's say you have negative numbers there are negative numbers, then you cannot size them to the area. But if you have positive numbers which have to be compared, that one is 2 times bigger than the other, then always use scale size area. So if you want to, I see Chowling is talking about Roslink. So there's a package called ggAnimate. ggAnimate, with which you can actually make it this kind of this animation, right? And you can see how it grows year by year. So ggAnimate package can make you animation, but we are not going to touch this today. Now, what I'm going to do now is I'm going to show you some of the features of ggplot. And these features are they are less important than what we have seen now, but I want to teach you some basics of some features of ggplot. It will be a might be not so interesting, but after this after knowing these features, you can create really nice publication ready graphs. We start with some additional geometrics. Please read in this PIAC dataset, and I'm going to show you some additional geometrics, and with each geometric I'm going to teach you one concept of ggplot. It's not a subset of area, but subset of this graph, yes. But now I'm going to
my question is that like this Gapminder, that the subset you created from the large data set, it is from like 1962 to 2007, or it is the subset of 1962 area and 2007 area?
1962, not area, but the population and GDP and this and 2007. These are only 2 years there.
Only 2 years.
Left in, yes.
So what if we want to create subset from 1962 to 2007, not the 2 areas, but within this time interval range?
Then what you would do then is some Gapminder is filter Gapminder year is bigger than 1961, year is smaller than 2008, for example. Then it has everything in between. I'm going to show you this filtering on one of the next lectures, how to create this. Now, let me show you some ggplot. I'm going to create a graph, ggplot. Data is PIAC, AES, X is, let's say, this numeracy variable. And I'm going to show you some geometrics which only use one aesthetic. So plus geom histogram. Now, and what this shows you is histogram of this numeracy variable. It creates these bins and it puts all the people inside these bins, and it shows you how is this numeracy variable distributed. Now, every geometric or most of the geometrics they also have some parameters which you can change. So for example, Geom histogram has bin width parameter. Bin width is, for example, 1. Now the bins where the people are put exactly 1 point wide, and creates this, every this, what is it now? This bin has only 1 point here, and it shows how many people have the value for numeracy test, how many people got exactly 60 or 200 or 300, and how many people are there. Or you can make bin with 50, then it shows you, then it creates these bins by 50, 50, 50, 50, 50, 50. That's how many people have this. So geometrics usually have these kind of parameters which you can change as well. How to know which parameters available? 2 ways. One is that when you have written this Geom histogram, then press tabulator, and the tabulator shows you what kind of parameters does it expect. Tabulator on your keyboard. The other way is to check, as you always can check Geom histogram, this help file, and go through this help file and see what kind of arguments are possible. Now to show this very same data, there are couple of different methods. So one we can also use ggplot. Data is PR, AES, X is numeracy plus Geom density. It shows the density plot. So what is density plot? It shows you what happened now. Geom density, I forgot this. I forgot the lines. It shows you the probability of anybody having this kind of numeracy level. So you can see that it is quite looks like normal distribution. It is something that you would expect, that this numeracy is normally distributed, that it is normal distribution. And what I want to show you in this Geom density is the difference between color and fill. So if you want to use now, if you want to group this data to 3 levels, for example, by education level. Again, I know what are the variables in PIAC, but you usually do not know. So what you do is you write names PIAC, and you see that there is a variable called education here. So let's see how different is numeracy by education level. So I'm going to write AES and connect color to education. And I have this. I have 3 graphs instead of 1. So the green one shows higher education, the blue one shows basic education, and the red one shows, sorry, the blue one shows secondary education, and the red one shows basic education. So you can see that the people who is smaller education levels, they are a little bit more stupid or a little less smart. So because the green ones, the people with higher education, this is to the right, you can see that these people have higher levels of mathematical abilities on average. But then again, these graphs are they are on top of each other. It means that there are many stupid people who have higher education, and very many smart people who have basic education as well. Now, this is what I did right now. I used color parameter, but let's see what happens when I use fill parameter instead of color. You see the color colors the line of the graph. But if I use fill parameter, then you see what happened. It fills it inside this. Now, as it is over plotting other graphs, other these mountains here, then what you want to do is you want to set alpha to be something like 0.5 or something like this, so that you can see through, and then that all these three will be on top of each other, but you can still see what is it. Charlie, I will show you soon how to change colors so that to our lightnings. I will show it to you soon. Another important plot type is Geom Bar. Let's look at what happens if we use Geom Bar. So ggplot PIAC AES X is, for example, education. I will copy the code here. You have the, but I don't know if you can copy paste it all back. I copied. I don't know. It looks funny a little bit. So ggplot PIAC X is education plus, but it only copied on the edge. You want to remove the black lines on the edge, then say not only fill is education, but also comma color is education. And now it doesn't have these black lines anymore. What I want to show you now is Geom Bar. And you see, it creates a bar plot. It counts how many people have basic education, how many people have higher and secondary education. You see that it's not in correct order. We will soon see how to convert them to correct order as well, that basic, secondary, and higher. But you see that there are only very few people in this data set who have basic education. Most of the people have secondary education, and then some people, and the second largest group is people who is higher education. Now, what do you think? What happens? No, this is not means. This is number of people. Number of people. It's there. If you look at me very closely, then you will see that my eyes are quite red. So, what do you think? What happens if we put sex in the bar? We put people in the bar. There is not mean number of people. It's number of people in this data set. So let's try it. Let's put men and women in the bar. And if we put men and women in the bar, what would you expect would happen if men and women are in the bar? Let's try it. Let's add AES and connect. Let's say connect fill is gender. And you see what happened. Females are on top of males. Sometimes this is exactly what you like. Sometimes you want a different position. So to have a different position, let's write comma, and then I'm going to show you some new positions today. And position is Dutch consonant. And now you have females next to males. So every geometric actually has some kind of position connected to it. And this default position is usually what you want. But you can change this position. For example, position is Dutch. And now men and women are females and males are next to each other, not on top of each other. There are some other positions available. So one position is, for example, fill, Ctrl Enter. Now it shows the proportion of males and females in the data set. So you see in higher education, there are much more females than males in this data set. It shows the proportion, and then there is position called stack. This is the default position. This puts men on top of females. The females on top of males, sorry. So this I wanted to say. Okay, now look at it. Don't do it with me. Actually, you can control this position argument very, very, very precisely. So if I write position is not dodge, but position dodge, then I can also write something like width is 0.5, for example. And you can you see that now it is not next to each other, but it is on top of each other. You most certainly do not need this kind of control. But if for some reason you need this kind of control, then yes, ggplot has you covered. You can do all kind of these small changes to the data to the graph. Usually you do not need it. Usually you just use position is dodge. That's it. It's straight. If you want proportion, then you would say position is fill. And now you have you have this. You want proportion on y-axis, then you would add plus labs y is proportion.
How to read this graph? Like it would be like males are 60% and females are 40%. We will read this graph like this. Like the basic education of males is 60% and the female is 40%.
You will read this graph that the data in this data there are more males with basic education than females with basic education. In this data, there are more females with higher education than males, and in this data, it's approximately on average, approximately the males and females with secondary education are approximately 50%.
Okay.
It counts the values of how many times it sees this basic higher or secondary education in the data set. Now, today, when you see your significant other, then you can tell him or her that, hey, I learned a new position today in the R class. And then you can say them position stack or position fill. And that you can tell them that you see females don't have to be on top of males, but they can also be next to males in the bars. Now, I want to show you one more position. So ggplot, let me try to visualize Piak again, saying that X is education, and for example, Y is income plus Geom point. If you visualize this kind of things, then you see that education is exactly higher than all the points overwriting each other. Can you label values in the graph? Yes, you can label values in the graph. We are looking at this a little bit later as well, but this is actually labeling values in the graph on ggplot. This is a hard part, but we will look at it. Now, you don't want these points to be on top of each other. You want them to be a little bit jittered. And then what you would use is position is jitter. And you see what it does now. It jitters the points around. So now you would also add that study that I will write it inside here. So this is how to read Piak. So this jitters the points, and you can also, for example, it is still overwriting the points. So if you want to see where is the mass of the points, you would make it alpha is 0.5, size is 1 or something like this. You make the even less, size is 0.5, so that you would see where is the mass of these points. This is something that you would need quite often. Now, how I would visualize this kind of data, I would add after the points, I would add plus Geom box plot. And now with this box plot, I would add alpha is 0.4 something, so that the box, not 0.4, let's say 0.7, so that the box plot is on top of the points. And it will show you the distribution of the points. Where is the median? Where are 50% of points? Where is 25th percentile? This box shows you that 25% of these dots is below this box, 25% of the dots is above this box. And as you see, this box plot also, it plots the extreme values. To remove them, because you are already plotting the dots anyway. To remove them, then then you would say outlier shape is not available, and now it doesn't show the extreme values. Now you have the plot, the dots, and also the box plot on top of it. Now let's go to next topic, and the next topic is, now I talk to you about positions. So position jitter, position dodge, position fill, and position stack. Pretty neat, isn't it? Yes. Now scales. Let's take the same last scales. What the hell? Scales. Let's take the same plot here, and I am going to start to change the axis values. What if you want to, you see that by default it's at 0, 2000, 4000, 6000 here. But what if you want some other values there? Then you can say that plus scale y continuous. It is continuous scale that you are using here. It's continuous scale, and you say that scale y continuous breaks are, and the vector of breaks. For example, 0, 1000, and 5000. Control Enter. And you see it shows you 0, 1000, and 5000 instead of the default values. Now you can also change how these breaks look, labels of these breaks. So I had a vector of 3 here. Breaks is 0, 1500. If I want to change what is you have position, not position. Between Geom point, you see inside Geom point, you have position, not position.
Thank you.
So I can also give it a new parameter inside the scale y continuous. I can say that labels is, for example, vector. I need to have 3 labels because I have 3 breaks. So labels is, for example, small, big, very big. And now it shows, you see, small, big, and very big instead of this 0, 1000, and 5000. So every aesthetic has a scale. Every aesthetic has a scale. So if we will changing this y scale, then it's this y aesthetic scale, then it is scale y continuous. But before we had this scale size area. So every size has a scale of scale size, blah blah blah, and so on. Now, color scales and legends. Color scales. How to change colors. Let me create you a graph again. So ggplot peak. Yes, let's say x is, for example, there is educat6, a variable called educat6 in this data set, plus Geom Bar fill is, sorry, AES fill is educat6. So I just want to create you a graph that has some colors on it. So it doesn't look nice. Let's add one more parameter here, comma let's say, so legend is false. You see, I just wanted to create a graph with some colors. Now about colors, how to change colors. R supports a number of palettes, color palettes, and I want to show you some of them now. I want to show you what kind of color palettes R supports. Make you some examples of this. So if you go to site called oh dear, color brewer. If you search for color brewer, then you will find a site called colorbrewer2.org. Going to copy you the link in a second. And this provides a number of different color scales, sequential scales, diverging scales, and qualitative scales. So you can choose your color scale from here, for example. And why I like this site is that it also gives you option to, let's say it has to be colorblind safe. Very many people are colorblind in the world, very many men, 5% of men or something like that. 4% of men are colorblind. So in many cases, you want your graphs to be colorblind safe. Charlie, yes, you see, you have already one person from here who is colorblind. So you want to select, in many cases, you want to select colorblind safe color schemes. So diverging, sequential, qualitative. But you see, it also says that number of data classes. If the number of data classes is 5, then qualitative data scales is not available here anymore. But diverging colors are available, which are colorblind safe. Now, ggplot supports these colors by default, so that you can add, for example, you can say that. So here it says it is 5-glass red blue RDBU, 5-glass RDBU. You look at this name here, and then you are going to put it directly into your graph. Let me show you how. Plus scale fill viewer palette is RV Boo, and it shows you this color palette from the comes. This is one of the color palettes we could select from there. There are other color palettes that you saw and so on. Now, if you use continuous color scales, you want the color scale.
And the previous one as well. My previous one is not working, so I'll check it out later on what's the mistake.
Now, I want to show you one more color palette that I'm very much suggesting you to use. Let me share my browser again. So if you want to visualize this kind of continuous colors, then you should use scale color viridis. And why should you use this? This is maybe you have seen this kind of colors before in some graphs, and many sites are using this. You might think that, hey, why am I using the same colors as somebody else? But these colors, this viridis color scale, this is scientifically proven to be one of the, you see what it says here, use the color scales of this package that make plots that are pretty better represent your data, easier to read by those with color blindness and print well in grayscale. So these colors are these scale colors we read is these are colorblind safe colors. These are colors that when they change from, I don't know, from 5 to 6, this change is perceived similarly from when it changes from -6 to -5 or something like this. And it's really nice looking. It is you see this kind of colors. I very much suggest you to use this color Viridis color scale. Now let me share my screen again. This is my R again. So how to use it again? This Viridis color scale is built into ggplot. So scale fill Viridis discrete. Oh, it would show you a discrete color scale, but it also has Viridis C, which is continuous color scale. Again, this is colorblind safe. It's as good as it gets, and I am very much recommending you to use these colors. Sven, I didn't. Sorry, I have sent a direct message. This code. I sent the code, but I sent it to somebody.
Okay.
I thought that I have sent it, but did not really. Now you have this code. No. Yes. What? No, for some reason I sent it.
And the color schemes as well.
Now you have this code. Okay, so this much about color. Okay, not this much. Let me continue with colors. So if you want to select the colors yourself, if you want to select that, let's say that low education is red, medium education is blue, and high education is orange, for example. Then what you would do? You would do ggplot BR AES, let's say X is education plus Geom Bar. And let's say fill is AES, fill is education, to make it colorful. Now, if you want to select colors yourself, then this is done like this, plus Geom fill manual. So we are selecting colors, fill colors now, manual. And now inside this Geom fill manual, you say values are. You can use Viridis here as well, sir. But I want to select it's my own values, give it my own values. So values are, and now a named vector, and the name vector looks like this. So let's say basic is red. Let's say higher is, I don't know, orange. And let's say secondary is, what color can secondary be? Let's say it is, I don't know, black. What did I do? Not Geom fill manual, I mean scale fill manual. And you see you have these colors what you want. So in many cases you want, let's say, always the higher education to be orange throughout your report, throughout your this whatever you're doing, your article, and then you would use this scale fill manual or scale color manual, giving it this values vector. Values is vector, what is which color, what is which color, what is which color. And so you can change the colors and keep all of your colors to be consistent. And and nice. Now, I have a small your turn. Let's try it. Let's try to download one dataset. So please install. Let me try it myself first. Library VB-stats. This is World Bank statistics. And with this, let's please install this library by install packages WB-stats. Let's see if it works now. I think last time when I tried it, then it was not available, but I think it should be available right now. And then when you have installed the package, load it in and download this dataset. GDP is, and I'm going to copy this link to you. This is your turn at page 7. I'm going to copy this to you. And there is your turn at page 7. And please, I'm giving you some time to create it. And I am to try to visualize this data, to first filter this data to select only 3 countries from this data set. And then let me take a quick look at this data myself. So it has date, it has value. Date CT, it has SPL, GDP, PC. Let's see, the date CT is actually date format. So what I want you to do is visualize it so that to put this date CT variable to x-axis, the value to y-axis, and visualize 3 countries on the same graph. And I'll be back in a second. See if you manage to do it.
That
Yes, it's fair.
I have a question that when we were doing that position is equal to fill, when we were trying to apply the proportion, so I can share the code. So in this case, the 2 graphs were stacking on each other when we were trying to find out the proportion. What if we do not want them to stack on the top of it, but to be adjacent to each other? So
Then
then
you will
how
need
can
to find the proportion first and then graph it. I will show it on later lecture when we are going through the deep layer.
Okay.
So how are you doing? Did you manage to do this graph?
Yeah, I did it.
And others, did you manage? Because this is, and then I would add just plus facet wrap till the country, then to make it, and you have this graph as faceted graph. If you want to make it a little bit more nicer, then you would add plus term minimal, for example. And this is how I would present this graph. You see that the date CT, it has a lot of numbers over plotting here. What you can do is you can add plus scale x date, because now it is date scale. And for example, there are a lot of, you can add date breaks is, I don't know, 3 years. Let's see what happens now. Now it puts okay, it's let's say 10 years. Let's say even 10 years, and then date labels is, let's say, %y, then it shows only the year number. %big Y shows you the year number in for
The %y, where is that?
what?
So like you wrote date labels is equal to %y, but I can't see that in the graph.
It shows now, it shows in the graph, it shows now %y means that this is a year. So if you look at the graph now, then it shows 1998, 2008, 2018. This is a %y. It shows year. So go, if you want to know this date labeling a little bit more, then check the help file of ScaleX date, and you will see that you can control it pretty nicely, that you can put months on there or weekdays or whatever you want.
And what if like we want the original, like what is in the data set, so we want it to be arranged like that, because we have seen that when we work on data set, our language automatically decides the X labels, but we want it according to our data set, like whatever, like the date CP is mentioned in the data set, we want it to plot like that. Then how can we do that?
I couldn't understand it very well now. R is putting you this automatically if it's date, if this is a date scale.
But I want that the date, the x-axis should be labeled according to the date that is present in my data set. If there are if there is an interval of 2 years, then it should show the 2 years. And after that, there is interval of 10 years, then it should show 10 years, like the way it is mentioned in the data set.
Then you have to control it by this breaks argument. That breaks is, and then vector of values which you want to be there. If you want to show every single value that is in the data set, it will overplot it, but you can for example say that breaks is unique GDP small dollar date. Now it shows no, it does not. Unique GDP dollar date GT like this. Now it shows every single value that you have in the data set, but it's overplotting it. Okay. Now actually, people, you actually know pretty much everything that is needed to know about ggplot. There are a lot of different options in ggplot that you can, make your graph a little bit more nicer and so on. And I love to play around with ggplot and make these small additions to everything. We will use this ggplot later as well, when we are going to go to dplyr, and then I will show you how to make this geom columns and stuff like this. But it actually, the basics is what you have gotten already now. If you can create this kind of graphs, then you can create almost anything right now. Let me see what I have, what I have in this data set. Give me a second. Let me see what I have in the materials, what I wanted to cover today as well. So actually I have some theoretical parts now coming. Let's go through one theoretical part before we end today. And this is writing functions in R. I'm going to show you how to write your own functions in R. And it's actually surprisingly easy. I'm going to write a function to you right now, and just look at it. Look at what I'm doing. So I'm going to create a function called times3, and I'm saying that this is a function that gets an input as x. Now I'm going to write these curly brackets. Oh, Pasant, you have. It really should work, Pasant. I do not believe that it is not working this facet wrap. Do you have library tidyverse loaded? It really should work. I kind of can't believe that it is not working for you. Now, okay, so back to the function. So I created a function which name is times3. And I said that it is function that requires x as an input. And inside this function body, I write that result is x times 3, and then I write return result. And now when I load this function, console enter, select it and console enter, then can you imagine what I can do now? I can do times3, x is 5, console enter, and it's actually 15. This is how people create functions in R. It is as easy as this. You say, for example, you say you create a function, for example, multiple divide is a function. Let's say it requires x, then it requires multiplicator. But let's put multiplicator to be as 3 and divisor. Let's set it as 4. So let's set it as 1. And function body. Let's say that function body is result is x times multiplicator divided by divisor and return result. And let's select this, and you have a new function multiple divide where you have to set x is, for example, 5. You do not have to set multiplicator or divisor, as these are default values is 3 and 1. So it makes 5 times 3 divided by 1, but you can change them. For example, multiplicator is 2. Multiple divide, x is 5, multiplicator is 2, and what you get is result is x times 2 divided by 1, it's 10. Now, this is how people make functions. When you write this kind of very good function which does something actually valuable, then you can save this function to package. People load this package and can use your functions. Yes, I can copy the code to chat. So here we are. Right, and take a look at this function and try to think it through. Then you can give them, you can also say divisor is, for example, 3 and it's 5. So it makes 5 times 3 divided by 3, and you have created a new function. Okay, you see, people, I am really tired today, so and this should be fun, but I don't feel like I am very active right now. So I suggest that we end a little bit early today, and I'm going to go through next time. We are going to go through some other things. Maybe next time I will be going. Maybe next time I'm going to give you a something about statistics without R. But not during this week anymore. I will have a free weekend. My girlfriend told me that she requires me throughout the weekend, and I will. So it will be next week.
On Monday.
What?
So your next session will be on Monday.
I think on Monday would be good. Yes, let me pause, quit the
Can we
recording right
go?
now. We can do loops on next lecture. Yes. So not next lecture. I don't know. Let me